First up, a large volcano in the southwest of Iceland has erupted after weeks of earthquakes. Take a wee look at this.
Scientists have stumbled upon an astonishing discovery in Iceland, a land famed for its raw beauty and volcanic activity. Known for its rugged landscapes, with active volcanoes like Eyjafjallajökull, Iceland is no stranger to geological wonders. Yet, this recent finding, emerging from its volatile landscape, promises to redefine our understanding of the region. It's not just a case of another volcanic eruption or a shifting glacier. This is about unearthing a part of history hidden until now. Join us as we explore what this discovery means and how it challenges our perception of Iceland's already mysterious geology. Iceland's majestic landscape and volcanic history. Iceland, a unique island nation, stands as evidence of the raw power of nature. The country boasts of Europe's largest glacier, Vatnajökull, covering an area of around 8,100 square kilometers. Beneath this icy expanse, volcanoes like Grímsvötn, with the highest eruption frequency in Iceland, lie dormant, ready to awaken. The island's volcanic legacy is deeply etched in its history. Notable eruptions like the 2010 Eyjafjallajökull event, which disrupted air travel across Europe, highlight the global impact of Iceland's geology. This eruption ejected an ash cloud reaching altitudes of up to 9 kilometers and affecting over 10 million air travelers. Such events are reminders of the powerful forces shaping our planet. Iceland's landscape is a blend of fire and ice. Its terrain, sculpted by volcanic activity over millions of years, includes features like the famous geyser, which gave its name to all geysers worldwide. The island is also home to Gullfoss, a massive waterfall showcasing nature's might, and the serene Blue Lagoon, heated by geothermal energy. In medieval times, volcanoes like Hekla, often called the gateway to hell, added to the island's mystique. These natural wonders, coupled with folklore and historical accounts, contribute to Iceland's unique identity. This interplay between volcanic activity and glacial forces influences the culture and life in Iceland. Iceland's geological significance. Iceland's position on the mid-Atlantic ridge, where the Eurasian and North American tectonic plates meet, has unique geological significance. This positioning is the driving force behind the country's frequent volcanic activity and stunning landscapes. The divergent tectonic plates cause the Earth's crust to split and move apart, leading to the formation of new crust and numerous geological features. The island is known for its dynamic volcanic activity, with about 130 volcanic mountains, of which 18 have erupted since human settlement in 874 AD. The most active volcano, Hekla, has erupted over 20 times since Iceland's settlement, shaping the surrounding landscape. The 2010 eruption of Eyjafjallajökull is a recent reminder of the island's volatile nature, affecting millions globally. Iceland's geology also contributes to its rich geothermal resources. These natural hot springs and geysers, like the Great Geyser, which can spout water up to 70 meters high, are not just tourist attractions, but also vital energy sources. About 85% of the country's homes are heated by geothermal energy, showcasing Iceland's commitment to sustainable energy use. The island's unique geology has impacted its flora and fauna too. The hardy plant species and diverse bird populations, including puffins and Arctic terns, have adapted to the harsh volcanic environment. Iceland's glaciers, like the Langjökull and Vatnajökull, are among the largest in Europe. However, they're retreating rapidly due to climate change, affecting the island's water cycle and ecosystems. The implications of climate change in Iceland. In Iceland, the harsh reality of climate change is becoming increasingly evident, especially in its rapidly changing glaciers and ecosystems. Iceland's glaciers, crucial indicators of global warming, are melting at an alarming rate. Vatnajökull, Europe's largest glacier, has lost about 10% of its mass in the last century, with projections suggesting it could vanish entirely within the next 200 years. This melting transforms Iceland's iconic landscapes and has profound implications for its freshwater resources. The retreat of glaciers like Vatnajökull and Langjökull affects the flow of rivers and waterfalls, vital for Iceland's hydroelectric power, which provides about 73% of the nation's electricity. Additionally, the melting ice contributes to rising sea levels, threatening coastal communities worldwide. The impact extends to Iceland's unique biodiversity. The melting ice disrupts habitats for species like the Arctic fox and impacts bird populations dependent on cold environments. Iceland faces the effects of changing ocean currents and temperatures, which influence fish populations, a cornerstone of the country's economy. As ocean temperatures rise, fish species migrate to cooler waters, affecting Iceland's fishing industry, a significant contributor to its GDP. The country's response to these challenges is notable, with Iceland being a global leader in renewable energy usage and sustainable practices. The implications of climate change in Iceland illustrate a broader narrative of how environmental shifts can impact not just the physical landscape, but also a country's economic and social fabric. As a microcosm of global environmental change, Iceland's experience serves as a crucial case study in understanding and addressing the impacts of climate change. Environmental and safety concerns. While historically significant, recent discoveries in Iceland also raise essential environmental and safety concerns. The uncovering of the Viking-era cave system near Adi has prompted questions about the stability and preservation of these ancient structures. Given their age and newfound exposure, these caves risk deterioration or collapse. This could lead to the loss of invaluable historical data and threaten researchers and the environment. The inherently volcanic nature of Iceland's terrain adds another layer of complexity to the preservation efforts. The caves are situated in an area known for seismic activity, which could compromise their structural integrity. This concern is heightened by the potential for volcanic eruptions and earthquakes, common in Iceland due to its location on the mid-Atlantic ridge. There's also the risk of encountering unknown pathogens or hazardous materials from the Viking era within these caves. The untouched nature of these sites means they could contain ancient biological matter, which, if disturbed, might pose health risks. These environmental and safety concerns necessitate a cautious approach to further exploration and study. Ensuring the stability and safety of the caves is vital. It requires collaboration between archaeologists, geologists, and environmental scientists. There's a need for strict guidelines and monitoring to safeguard these historical sites against potential damage from natural elements and human interference. The discovery of the caves is a significant milestone in Icelandic archaeology, but it also serves as a reminder of the responsibility that comes with unearthing our past. Balancing the excitement of discovery with the need for preservation and safety is essential in maintaining the integrity of these invaluable links to our history. The shocking discovery, a link to the past. However, recently, Iceland has become the epicenter of a groundbreaking geological discovery. In the small town of Adi, Rangárvallir, Iceland has become the epicenter of a groundbreaking geological and historical discovery. Archaeologists have unearthed an extensive network of man-made caves, dating back to the Viking Age, around 800 to 1060 AD. This significant find, led by the Archaeological Institute of Iceland since 2018, offers a rare glimpse into the lives of Iceland's earliest settlers. Initially thought to be simple, medieval barns for livestock, the caves revealed a sophisticated system of interconnected underground chambers. This complexity suggests they served multiple purposes, possibly including storage, shelter, and livestock housing. These structures demonstrate the Vikings' remarkable ability to construct complex structures with limited technology, using the natural resources of their environment inventively. The importance of this discovery extends beyond archaeology. It challenges our understanding of Viking settlement patterns and their adaptive strategies in Iceland's volatile environment, marked by frequent volcanic eruptions and harsh weather conditions. How these early settlers built and maintained such structures amidst these challenges opens new avenues for research. Furthermore, this finding aligns with historical records like Bishop Einar Olafur's Legends of Saints from the 13th century, adding credibility to these ancient texts. It also raises vital questions about conservation and preservation. As these ancient structures, now exposed after centuries, reveal more secrets buried beneath Iceland's landscape, their stability and protection from environmental hazards become crucial. This discovery is a delicate part of Iceland's heritage, demanding careful study and conservation to ensure its historical value endures. The emergence of Icelandia and its global impact. However, the ancient cave system is not the only discovery in Iceland which has shocked scientists. The discovery of Icelandia, a massive submerged continent beneath Iceland, has sent ripples through the scientific community, redefining our understanding of Earth's geological history. Unveiled by an international team of geologists, Icelandia stretches over an area more than twice the size of California, potentially extending from Greenland to Europe. This finding challenges long-established theories about the Atlantic region's oceanic and continental plates. Icelandia's emergence has significant global implications. For starters, it could lead to a rewriting of maps, altering our perception of oceanic and continental boundaries. This discovery might also impact our understanding of the supercontinent Pangaea, which existed about 360 million years ago. The notion that a part of it stretched out, forming Icelandia, suggests a more complex history of continental drift than previously thought. The potential economic and environmental impacts of this discovery are vast. The possibility of new mineral and hydrocarbon resources within Icelandia opens up opportunities for exploration, which could boost economic prospects for countries in the North Atlantic region. But this also raises concerns about the environmental consequences of such activities. Disturbing the ocean bed in search of resources could harm marine ecosystems, affecting biodiversity and disrupting established ecological balances. The existence of Icelandia could influence global weather patterns. Its impact on phenomena like the North Atlantic Oscillation might alter climatic conditions in Europe and North America, with unforeseen consequences. The emergence of Icelandia presents a multifaceted scenario that demands careful consideration of its geological, economic, and environmental ramifications, offering a unique opportunity to deepen our knowledge of Earth's intricate history and ongoing evolution. The revelations in Iceland, from the discovery of ancient Viking caves to the emergence of the submerged continent Icelandia, present us with a profound reality check. These findings signify a pivotal point in our understanding of the natural world. As we stand at this crossroads, the challenge is clear. In our pursuit of groundbreaking advancements, how do we ensure a harmonious balance between the thrill of innovation and our duty to safeguard the environment for future generations?